So welcome to the topic of linear graph, that is changing nonlinear graph to linear graph. To begin with, just to focus nonlinear and linear graph. An example of nonlinear graph or equation is like the quadratic equation or cubic functions They are good examples of nonlinear graphs, such that they are not straight, or the cubic function whereby you find a graph of this nature with minimum value and maximum point. So such graph have equation of the form y is equals axn, whereby a and n are normally constant, or y is equals ax squared plus bx plus c, whereby a, b and c are constant. This is an example of a quadratic equation or cubic function, whereby we have ax cubed plus bx cubed plus cx squared plus d. This is a good example of nonlinear relation. Then for linear relation, we have y is equals mx plus a constant, whereby m and c are constant value. If you plot a graph of y against x, get m is the gradient or the slope, and also c is the y-intercept. So this concept will help us be able to work out on nonlinear graph to linear graph. So for us to work out nonlinear graph to linear graph, we normally introduce logarithms. So we shall see this in the next part. So we have the question here. It says two variables a and b are connected by the equation a is equal to kb raised to n, where k and n are constants. The table below gives the value of a and b. So we have the values of a and b. So for a, those are the corresponding values of a and b. So the question is, find a linear equation connecting a and b. Find a linear equation connecting a and b. So since a is equal to k times b raised to n, this can also be written as a is equal to k times b raised to n. So we are going to introduce laws of logarithm. We introduce laws of logarithm, whereby in multiplication we add. If we introduce log, we add. Therefore in our case, this will be log of a will be equal to log k plus, since it is multiplication, we add log k, that will be n log b. So the linear relation that connect a and b is now log a is equals to n log b plus log k. And if you wanted to prove, this is of the form y is equals mx plus a constant. If you plot a graph of log a against log b, it will be a linear graph whereby n corresponds to n. It will be the slope or the gradient of the graph, and then log k will be equivalent to c, which is the y-intercept. So we need to come up with a table of log a and log b, so that we are able to come up with a linear relation. So next part is, on the square paper draw a suitable straight line graph to represent the relation in A. So this is the relation. So we need to plot a graph that will represent this relation. So we need to make a table of values of log A and log B. So log A, so using the row for values of A, so log of 1.5 is given by, using calculator, get a 0.18. Then log of 1.95 we get a 0.29. Then log of 2.51 we get as 0.40. Log of 3.20 we get as 0.51. Then log of 4.50 we get as 0.65. The other part, log of B, so log of 1.59 get a 0.20. Then log of 2.51 we get as 0.40. And then log of 3.98 we get as 0.60. Then log of 6.31 we get as 0.80. And then the log of 11.5, that will be 1.06. So now we have come up with the corresponding values of log A and log B. So this is what will help us to draw a straight line graph to represent the relation log A is equal to n log B plus log k. Then from there we shall be able to answer the following question. We are going to plot a graph of log A against log B. So a graph of log A against log B. So the first thing you are going to do is to draw the, so we are going to draw the axis. So this particular point, so I'm going to draw axis. So from here that is the x-axis, and also I draw the other part which is the y-axis. So for log A, which is the y-axis, and log B, which is in the x-axis. So I'm going from the values on the table. Log A, the maximum value is 0.65. As I count from this, I can be able to, the scale that I'm going to choose will be able to fit very well So for both axes, I'm going to consider a 2 big square to represent 0.1. Even for the x-axis, that is log b, I'm going to use the same scale to represent. So from here, 0, then I have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, and finally 1.1. Y-axis 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. That is enough. Therefore, since both axes have the same scale, let me find the value of one small square, which will be 0.1 divided by 10, so which will be 0.01. That means the value of one small square is 0.01. Therefore, plotting, so 0.18 at this particular point, then log b is 0.2. So this is the marked point, plotted point. Then I plot the other point, which is 0.29 and 0.4. 0.29, so this particular point, and then 0.4 is here. So the point of intersection of the two, so this particular point. Then the other point is 0.4 and 0.6. 0.4 and 0.6. So this is the point. So I plot the point, put a mark at this point. Then the other value is 0.51 and 0.8. 0.51, remember one small square is 0.01. So here it is 0.51. Then 0.8, this particular point if I plot, it will be at that particular point. Then lastly 0.65. 0.65 is at this particular point, and 1.06 I mean, be at this particular point. Therefore the plotted points will be there. Then I use a ruler, I join all the points. So using the ruler, I join all the points. So that is the point. So that is it. So that is a point. So this is now the graph we have, and we have plotted a graph of log A against log B. So the next part is use your graph to estimate the value of k. So we are going to use the graph to estimate the value of k and n. That is, from the relation log A is equal to n log b plus log k. Since it is a linear relation in the form of y is equals mx plus a constant, that a graph of log A against log B is a straight line graph. Therefore, n will give the slope or the gradient. So for us to find n, will be change in log A over change in log b. For k, it is the y-intercept, so log k will be equal to y-intercept. Therefore, we need to get this from the graph, and from the graph we need to choose at least 2 points. I have to choose this point here. I choose this point, and also the other point that I'm going to choose, just a suitable point that I'll be able to read is, let me choose a different point apart from what I have plotted. This is the point I'm going to choose. Therefore, I draw this line. So this will be changing log A and then changing log B. So this point here, I can actually locate them. This will be 0.55, and the other point is a point which is 0.3, that is 0.3, 5, 6, 0.37. Then the other point here, that is 0.15. The y-axis, that is 0.15 also. Therefore, I can use the points that I've chosen to now draw to find the gradient. That is, this now will be 0.37 minus 0.15 all over, the other one is 0.55 minus 0.15, 0.55 minus 0.15. So I will end up getting, so I'll get 0.37 minus 0.15, I get 0.22 all over 0.55 minus 0.15, get 0.4. So if I divide them, I will end up getting 0.55. So this is the gradient, so that's the value of n. Then log k, so we need to find k, so log k will be equal to the y-intercept, and in our case here, y-intercept is the y-intercept, actually it's the 7th division from 0, so that will be 0.07. So log k be equal to 0.07. Therefore, for us to get k will be the anti-logarithm of 0.07, which is also the same as 10 raised to 0.07. So we shall end up getting 1.175, which is approximately 1.2. Therefore, n is 0.55 and k is 1.2. So thank you so much for watching. Remember to subscribe, like, comment, and even share to your friends. Thank you so much.